In this video, we're going to look at a long answer question, an example that asks us to make predictions about the shapes of molecules and ions. So here's our example. We're told at the start of the question, water molecules accept hydrogen ions from acid to form the H3O+ ion. And it then says use electron pair repulsion theory to predict and explain, so I'm underlining lots of things here, why the shapes and bond angles in water and the H3O+ ion differ. It also says I'm allowed to use diagrams in my answer. So with this question being 8 marks, it's actually designed as a level of response question. This means that you're likely to get 6 marks for content, what you actually write, versus 2 marks for how you write it, the structure and the logic or reasoning and the linking of different facts together. So it's a common misconception that, for example, if we have this kind of very long answer question, that we must have to write everything in full sentences, that we can't get marks unless everything is super grammatically correct. This question's not really about grammar, although obviously it does help because it makes your writing more understandable. This question is about the logic and the way that things are linked together. It even says you can use diagrams. So you definitely can use bullet points as well, and you don't have to sort of have everything as like really long trailing sentences. The other thing to realize is just because there may be 6 marks available for the content doesn't mean that we will get 6 marks if we write 6 points. Often in this kind of question, we are possibly going to be expected to do more than one thing for a mark. For example, we may only get 1 mark for predicting both the shape and a correct bond angle to go with that shape. So the question says electron pair repulsion theory. Make sure that we actually refer to that in our explanation. And the reason it's worth more marks is because we've got 2 molecules, or a molecule and an ion, that we're going to compare. So one of the first things I do, especially if it says I can use diagrams, is I would draw a dot and cross diagram for water, a nice easy dot and cross diagram if ever there was one. And then I'm going to think about how I would draw the hydrogen, sorry, it's not hydrogen ion, the hydroxonium ion, H3O+. It says it's formed when water molecules accept hydrogen ions. So what I would do is I draw my water molecule just as it is, and then it joins onto an H which doesn't have an electron, so that would be an H+, and then the whole thing would have a positive charge. Now the positive charge is not important really in this question, it's not important for the shape, but it is there. And I would then think about counting the areas of electrons. So one of the most important things that a lot of students miss is they don't explain the kind of the way that electrons spread out. They kind of go straight to the repulsion of lone pairs compared to bonds, and they don't really talk about like the number of sets of electrons and then therefore how that leads to a shape. Now I've actually shown the number of sets of electrons, but because I've drawn a dot and cross diagram, so I might get those points, but let's be super specific and say that water has 2 lone pairs and 2 bonded pairs, or you could just say of electrons, whereas H3O+ has 1 lone pair and 3 bonded pairs of electrons. So that is obviously going to be a key reason to the difference in the bond angles and also the difference in the shapes. But we also should talk about what's similar about them. They both have 4 areas of electrons. So what we don't want to miss is we don't want to miss saying what it is that electrons do. We don't want to miss talking about electron pair repulsion. So at some point we would like to say that electron pairs repel, and therefore they are arranged as far apart as possible. And it's really worth saying in a question like this where you are comparing different things, where some have different numbers of lone pairs, but they actually all have the same number of pairs. They all have 4 pairs of electron around that central atom. So you might want to say something about the actual angle it would be if they were all bonds. So if the molecule had 4 bonds and no lone pairs, the maximum bond angle would be 109.5 degrees. Some examples just call that 109. That's fine, just go with whatever it is that you know that you're seeing a lot in your mark schemes. So we're now going to just do the comparison. So we have stated the number of bonds and the number of lone pairs for the water molecule and for the iron. This statement about electron pairs repelling and being arranged as far apart as possible needs to go in every single one of your explanations about the shapes of molecules. And this idea about what would be the maximum angle if there were no lone pairs, then it would be 109.5. We can then go into comparison of the 2 molecules. And we want to explain why the angle changes, because otherwise, since they've all got 4 things, you'd expect the angle to be 109.5. So the second statement that we can say pretty much every time we do a shapes question is that lone pairs repel more than bonded pairs. That's really important as well. That explains why we have different angles because of different numbers of lone pairs. So we can say that water has 2 lone pairs, so the angle is reduced to 104.5, so we're taking off 2.5 degrees for every single lone pair. We should also talk about the shape. So the shape is non-linear. We don't really have to sort of go over explaining that. We have explained it. It's got 2 bonds and it's got lone pairs, so the bonds are going to be pushed together, so it's not going to be linear. That's it. And then we can do the same thing for H3O+. Has only 1 lone pair. So the angle from 109 is therefore 107. And the shape, because there are 3 bonds, is pyramidal. You can say, just underlining the key points there, you can say trigonal pyramidal. That's absolutely fine. What we mean is it is a 3-pointed pyramid, like it's got 3 points at the base. However, just be careful that you don't accidentally say trigonal bipyramidal, because that's a shape as well. You don't need the trigonal bit in. There's only one type of pyramidal shape in chemistry to be worried about. So we've counted the number of electrons, the lone pairs and the bonded pairs. We've talked about electron pairs repelling and then what happens in terms of maximising that distance between them. We've said what the angle would be without the lone pairs, and then we've stated that lone pairs repel more than bonded pairs. So therefore we have compared the two molecules in terms of the number of lone pairs and their angles, and also the difference in their shape. So just thinking about some last points on this question, using diagrams. You don't have to write everything for a long answer or level of response. Often they'll give you space for a diagram, and they even mentioned here that they want diagrams. Equations are also very common ways to get lots of marks in a level of response question. If I was using the diagram, then what we can use the diagram for is I can draw a diagram of water. I can show my two lone pairs, and I can draw a three-dimensional diagram of the H3O+. So because this is pyramidal, it's going to look like ammonia. Still going to have a lone pair. Just in case the mark scheme is being particularly tough, I'm going to put the square brackets and the plus around it. So you can use these to label your bond angles. So by doing all of this, you have basically already got the bond angles and the bonds, and you've shown the number of bonds versus the lone pairs. You would not get the mark simply for drawing the shape instead of naming it, because often they really are looking for you to know the name of the shape. You're most likely not penalised for sort of missing charges. Also, if I was being super strict, actually, like one of these bonds in H3O+ is dative. However, that's not really what they're assessing here, so they're unlikely to mark you down for it. So the things that people leave out is the part about electron pairs repelling and moving apart. Do that before you compare bonds and lone pairs. So make sure you talk about electron repulsion and the maximum angle before you move on to talk about those lone pairs. Then you can talk about lone pair repulsion, but don't forget somewhere to clearly state the number of pairs or areas. If it's double bonds, it's not going to be a pair, it's going to be 4, but it's still going to be one area. And you're going to separate that into the number of bonds versus the number of lone pairs. And that's how you get really high marks on a shapes of molecule or ion question.